Next, our question is a standard air-filled rectangular waveguide with the dimensions A equal to 8.636 cm, B equal to 4.318 cm is fed by a 4 GHz carrier from a coaxial cable. Find whether a TE10 mode will be propagated. If so, calculate the phase velocity and group velocity. So we can see that to check whether it is in propagation mode or not, first you need to find the cutoff frequency. So if the frequency given is greater than the cutoff frequency, then we can say that the mode will propagate. So for a frequency if greater than the cutoff frequency, then we can say that it is a high pass filter. So we already said that this waveguide will act as a high pass filter. So after cutoff frequency only they will propagate. So if our given frequency is greater than the cutoff frequency, then we can say that the wave will propagate. So first we need to find the cutoff frequency. So it is T10 mode. So we can say that m equal to 1, n equal to 0. So our cutoff frequency equation is u dash by 2 root of m by a whole square plus n by b whole square. That's the general equation. In that m is 1 here, n is 0. So we have root of 1 by a whole square, that is 1 by a itself. So our fc is u dash by 2a. So u dash, we know that this waveguide is air filled. It is said that it is air filled. So for this u dash is velocity of light itself, 3 into 10 raised to 8. So we can find fc as 3 into 10 raised to 8 by 2 into a is 8.636 into 10 raised to minus 2 in meters. So all the things should be converted to meters. So you will get it as 1.737 gigahertz. So our cutoff frequency is 1.737 gigahertz. So any wave which is greater than this cutoff frequency will propagate. So our given frequency is 4 gigahertz. So obviously it will propagate. So we can say that the TE10 mode will propagate. Then we need to find the phase velocity. If it is propagating, then we need to find the phase velocity and group velocity. Phase velocity is u dash by root of 1 minus fc by f whole square. So remember here it is air filled. So this u dash is 3 into 10 raised to 8 by root of 1 minus fc by f whole square, that is root of 1 minus 1.737 by 4 whole square, that is 3.33 into 10 raised to 8 meter per second. Then we need to find the group velocity. You can use the equation, that is u dash into root of 1 minus fc by f whole square, or you can use the relation as this vp into vg is equal to v dash square, or here if it is represented as up into ug is equal to u dash square. That means this multiplication of phase velocity and group velocity is square of this square of this velocity, that is velocity of light, or c square we can write here. So this ug into vp is ug into up, or vp into vg is equal to c square here. So we'll get vg as c square divided by vp. So c square is 3 into 10 raised to 8 square divided by vp is 3.33 into 10 raised to 8. So you will get it as 2.702 into 10 raised to 8 meter per second. Otherwise you can find it as vg is equal to u dash, or ug is equal to u dash into root of 1 minus fc by f whole square. So this way we can find the propagation mode as well as phase velocity and group velocity. So to check whether a mode is propagating or not, you can check whether the given frequency is greater than cutoff frequency. So if the given frequency is greater than cutoff frequency, then this wave will propagate. So that time this propagation constant purely imaginary. That means alpha is equal to 0 and gamma should be j beta. So remember, if the given frequency of operation is greater than the cutoff frequency, then the wave will propagate. Then this propagation constant gamma is purely imaginary, that is gamma is equal to j beta, as we did here, as we did in this example 12.3. So if this cutoff frequency is if the given frequency of operation is less than the cutoff frequency, then we can say that it is not in propagation mode, it is in evanescent mode. So that time this gamma is purely attenuation constant alpha. So if if it is in cutoff frequency, then also there is no wave propagation. So to check this propagation mode or evanescent mode, we have two conditions. We can check whether by using this cutoff frequency or by the equation omega square mu epsilon is greater than m pi by a whole square plus n pi by b whole square, then we can say that it is in propagation mode. And if it is omega square mu epsilon is less than m pi by b a whole square plus n pi by b whole square, then we can say that it is in evanescent mode. So otherwise you can easily check by using the cutoff frequency. So check whether the given frequency of operation is greater than the cutoff frequency, then that will be in propagation mode. So that time this propagation constant is j beta itself. And if it is if the given frequency of operation is less than cutoff frequency, then it is in evanescent mode. That means there is no propagation. That means the propagation constant is purely attenuation constant itself, that is gamma equal to alpha itself. So this way we can find whether the wave is in propagating mode or non-propagating mode.